This video will show solutions to the 2017 VCE Mathematical Methods Written Examination 2. Section B, Question 3. Question 3. This question involves a probability density function of a piecewise nature. Because we're going to work with this function in a number of ways during the question, it is worth defining it on our class pad. First, I'll call up the piecewise template, which is under the Maths 3 keyboard. Normally I would use the variable t as defined in the question. However, as I wish to graph this function, I'm going to use the graphing variable x. With this done, we can obtain a graph of f on an axis like the one provided. First, I'll set the view window to match the axes as shown in the examination. Now I can drag and drop my function to see its graph. This graph needs to be drawn accurately. Due to its straight line nature, a ruler should be used. Unfortunately, I don't have one available, but hopefully you do. The regions where the probability is 0 should also be indicated by drawing a line along the t-axis. This gives us a bit of a picture of the behaviour of this function. Part B. We can find the probability required using a definite integral to calculate the area beneath the probability density function. Giving us an answer of 0.8. Part C. To find the probability of t less than 25, given that t is less than 55, we need to find the probability of t less than 25 divided by the probability that t is less than 55. And this can also be done by calculating definite integrals. With these two probabilities calculated, the required answer can be computed. Part D. We are asked to find A such that the probability of t greater than or equal to A is equal to 0.7. This looks something like this. If we use the fact that the area up to and including A is equal to 0.3, then this statement is equivalent to the following integral equation. And this equation can be solved on our class pad. Converting our answer to decimal form gives us an answer in the domain of the function of a equals 39.3649 to 4 decimal places. Another approach to this question would be to set up the integral equation using the piecewise function. It is worth remembering, though, that exact solutions are hard to obtain using piecewise functions. So, as we only require a 4 decimal place answer, we will solve this equation numerically. We should use the left and right boundaries on the triangle as our lower and upper bounds. That would be 20 to 70. And we should provide an initial value which is close to the answer. I'm going to use 30. After a few moments' thought, our class pad returns the same answer, 39.3649. Part E. Now we are focusing on Jennifer spending more than 50 minutes on her homework, which occurs with probability 8 out of 25. And we are considering 7 randomly chosen independent days. Hence, if we want to know how many days out of 7 she does her homework, we should consider the binomial variable x. And the probability required in part 1 is the probability Jennifer spends more than 3 out of 7 days, which would be 4 or more days out of 7. This can be calculated using the distribution command in main menu. Giving us a probability value to 4 decimal places of 0.1534. E part 2, we are asked to calculate the probability that Jennifer spends at least 2 days on her homework, given that she spends at least 1. The value of this fraction can be calculated using a similar structure to the one used in part 1. Changing the top line to go from 2 to 7 and the bottom line to go from 1 to 7, we can obtain the probability required. Part F, we now require a polynomial for Q in terms of P, where P is the probability that Jennifer spends D minutes on homework on any given day. Q's probability is based on her doing 2 or 3 days out of 7. In other words, it will be equal to 7 choose 2, P to the 2, 1 take P to the 5. That will be 2 out of 7 days homework being completed, plus 7 choose 3, P to the 3, 1 take P to the 4, which would be 3 out of 7. This polynomial can be generated and simplified on our class pad. The combinatorial choose command can be found under the advanced keyboard. That provides us with the first term in our polynomial. With a little modification, we can obtain our second term too. We can add these two terms and then simplify the answer. This gives us a simplified version of the polynomial Q, 7p squared by p minus 1 to the 4 by 2p plus 3. G part 1. To find the maximum value of Q, we can use the fmax command. As the variable is p, and p is a probability, we need to set the start and end values to be 0 to 1. This gives our maximum value of Q of 0.5665, and the corresponding value of P as 0.3539, both to 4 decimal places. G part 2. This brings us back to the distribution of T. Now we're asked to find the D value that corresponds to the probability found in part 1. In other words, this area is our p-value 0.3539, and D is the cutoff for which this area occurs. Hence, we need to solve the integral equation d to 70 of 1 on 625 by 70 minus t dt equals 0.3539, a p-value. This gives our value for D as 48.96, or as we're after answer to the nearest minute, 49 minutes.